Good evening, Anglesey. This is Science of Santa. And what I'm going to do this evening is basically ask the question, is Santa compatible with the laws of physics? Or a slightly more succinct way of saying it, just how many laws of physics does Santa actually break? So we all know that Santa is, at least allegedly, a portly, jolly fellow with a white beard and a penchant for wearing red suits. But just because he displays questionable fashion sense, that doesn't, of course, mean he cannot exist. So what about the claims that are made of Santa at this time of year? He allegedly visits all households on Christmas Eve to deliver presents to all qualifying children. And in this context, qualifying children is defined by his naughty nice list. Can we reconcile these incredible feats attributed to Santa with our understanding of science? And in particular, given that I've given a lot of different talks about how we understand the way the universe works according to the laws of physics or science, can we understand what Santa is doing using any of the science described in a handful of my other talks? Here's a smattering of some of them that look at how the universe, how the world works. So I'm going to pick out various aspects from these talks and see if it helps us answer any questions about how Santa does what he does. So let's just take those alleged feats again. There it is. Santa visits households on Christmas Eve to deliver presents to children. And we're going to effectively unpick that one word at a time and see if it makes sense. So to start with, let's just figure out how many children we're talking about. So, how many children get presents at Christmas time? Well, the Earth's population is about 8 billion, and approximately 25% of the Earth's population are children. Let's assume, just to keep the maths nice and easy, that half of them are eligible for Christmas presents. In other words, Santa delivers presents to children even if those children might not be in Christian households. Santa's a fairly generous fellow, so it doesn't really matter what the religion of the household is. Let's assume half of those children get presents. So that works out to about 1 billion children get Christmas presents. And again, just to make the maths easier, I'm just assuming that the naughty nice list separates into naughty 0% and nice 100%. Any parents or grandparents in the audience might well question those numbers, but let's just assume that to make life easier. So 1 billion children, what's the next thing we're going to check? Visits. How does he make the visits? What's his mode of transport to get around the world? Well, we can ask the question, can reindeer fly? Well, we know that insects can fly, and we know that birds can fly, and we know that pterosaurs can fly, even though you don't see many of them these days. And we know that mammals can fly, or at least some mammals can fly. So the question is, can reindeer fly? Well, if they can fly, they choose not to do so for a lot of the time, because there's essentially no photographs of flying reindeer. So there is very little evidence for reindeer being able to fly. But remember, in science, absence of evidence is not the same thing as evidence of absence. So just because we haven't got any images or photographs of flying reindeer doesn't mean they can't. Much like we have no real evidence for flying saucers or UFOs, but people claim they exist. So the jury is still out on that one. How fast would Santa have to go? How fast would Santa and his sleigh have to fly through the atmosphere? Well, we can sort of work out where these billion children might live. We can either assume they're uniformly distributed over the Earth or uniformly distributed over the landmass of the Earth. And to visit 1 billion children in one night, let's assume that's 36 hours. He doesn't just have the 12 nights. There's 12 hours of night. Let's assume that he uses the 24-hour time zones to his advantage. So he's actually got about 36 hours in which to deliver the presents. We can calculate that he would have to travel at a minimum of about 2,000 kilometers per second. And that sounds like an awful lot, but when you convert it into a fraction of the speed of light, it's only 0.007 of the speed of light. And we know the speed of light is a speed limit, but Santa is only moving at less than 1% of the speed of light, so is not breaking any laws of physics. In a talk that I call Fiat Lux, Let There Be Light, I actually measure the speed of light, and it turns out to be 300,000 kilometers per second. We know that is ultimately a speed limit. No object can travel through space faster than light can travel in a vacuum at 300,000 kilometers per second. Now, we know that we live in an expanding universe, and space itself is actually expanding faster than the speed of light, but the speed of light is a limit only in terms of objects moving through space. Space can expand at any speed it wants to, and it turns out to be a lot faster at great distances, and certainly a lot faster in the past. So, speed limit, not a problem. However, if he is moving really fast, wouldn't the sleigh and the reindeer burn up? Wouldn't we be looking at roast reindeer? If an object is moving through the Earth's atmosphere at incredible speeds, surely it's going to heat up. We know that as meteors or asteroids that enter the Earth's atmosphere, we know they heat up and glow because the air in front of the meteor or the asteroid gets compressed. And surely that will be the same for the sleigh. The air in front of the sleigh will be compressed by its speed through the atmosphere, and it would heat up. Some people think that asteroids heat up because of friction. It's not, strictly speaking, friction. It's the compression of air in front of the object that makes it hot and makes it glow. This is part of a talk I give on the ABC of stellar evolution, and the C of the ABC stands for compression produces heat. In other words, when a large cloud of hydrogen compresses to form a star, that's why a star gets hot, because the hydrogen cloud gets compressed and compression produces heat, and the star gets hot, and ultimately nuclear fusion starts at its core. So if the sleigh and everything else, the reindeer and Santa, are moving really fast through the Earth's atmosphere, surely the compression would result in the sleigh getting very hot. Even if it's aerodynamic, surely it's still going to get hot and it's going to glow. Wouldn't the heat make the sleigh glow white hot? Well, ordinary matter, when you heat it up, hot objects radiate light. If you take a brick and heat it up, after a while it gets red hot. If you keep heating it up, it'll eventually get white hot. So surely that means if Santa and sleigh are moving fast through the Earth's atmosphere, they ought to be very easily visible as a bright object in the sky. Well, maybe they were. But I think it's pushing it a little bit to claim that Santa and his sleigh were actually responsible for the Star of Bethlehem. The timeline doesn't work out. But if you think the sleigh ought to be glowing quite brightly in the night sky, well, maybe it is visible. Plenty of people claim to see bright objects in the night sky, not necessarily only on Christmas Eve, but plenty of people have claimed to see UFOs. So maybe the sleigh on Christmas Eve is just one of those bright lights in the sky. But there's an alternative, because of course we know about certain stuff that does not emit or absorb or reflect light, or indeed any other type of electromagnetic waves. If you take this matter and heat it up, no matter how much you heat it up, it doesn't give off light. What type of matter is that? Well, it's dark matter. Unlike ordinary matter, which will give off light when you heat it up, dark matter doesn't behave that way. Okay, so maybe Santa and his sleigh are made of dark matter. That not only explains why you don't get bright lights in the sky when the sleigh is darting all over Earth, it also explains why the sleigh doesn't show up on radar, because radar is just an electromagnetic wave, microwaves, and radar will not be reflected off the sleigh if it's made of dark matter. The radar will simply go through the sleigh and there will be no sign of it on a radar screen. So maybe that kills two birds with one stone. So we've dealt with children and we've dealt with how Santa visits. But now let's deal with what he visits. He visits households. Right, let's get the perennial problem out of the way first. Chimneys. How could Santa get down so many chimneys? If we do a simple calculation, if we want him to visit a billion children in one night, he would have to squeeze down at least 3,000 chimneys each second. How can Santa possibly do that? His waistline, surely, is far too large for him to get down a chimney very easily, let alone very quickly. Well, there are ways that that could be done. Santa, like the rest of us, appears to be made of molecules which are made of atoms, and atoms have a characteristic distance between them. But if you were to take all the electrons in an atom and replace them with a similar particle called a muon is a sort of heavy cousin of the electron. It has a lot of similar properties, except that it's 200 times more massive. If you take all the atoms in Santa, keep the nuclei the same, but replace the atomic electrons with muons, then all the atoms would be 200 times smaller, which means Santa would no longer be a person about a little less than 2 meters tall. He would only be about 1 centimeter tall. And hence he would fall down a chimney no problem whatsoever. So we know that atoms made with muons would be smaller. Now, I don't know how Santa replaces all his electrons with muons, but if he were to do that, he would instantly get a lot smaller and he would go down the chimneys without a problem. So maybe that's how he does it. But that doesn't help if a house or an apartment doesn't have a chimney. So how does Santa get inside a household to put the presents under the tree if he hasn't got access via a chimney? Well, strictly speaking, he doesn't need access via a chimney. He doesn't need an open door. He doesn't need an open window. Because it's possible to get from inside a household to outside, or vice versa. It's possible to get from outside a household to inside via a process called quantum tunneling. Quantum mechanics, or quantum theory, allows an object to get through a so-called solid object like a wall. We don't need an open door, we don't need an open window. It's possible for an object to quantum mechanically tunnel through a solid wall and get to the other side. Isaac Newton wouldn't allow this. According to classical mechanics, you can't do that. But we live in a quantum world. Atoms have been shown to be able to do that. If atoms can do it, then molecules can do it. And if molecules can do it, then why can't Santa do it? It's allowed by the laws of physics. So maybe that's what he does when he doesn't have access to a chimney. Okay, we've looked at children, we've looked at visiting, and we've looked at households. He does this on Christmas Eve. So then there's the question, how does he do this all in one night? How can he make so many deliveries in only 36 hours? Even if travelling at relativistic speeds between each delivery, it's still pushing it a bit to get it all done in 36 hours. Well, subatomic particles, we know, can be in 2 places at one time. So an electron can be in 2 places at one time. An atom can be in 2 places at one time. So if it's possible for subatomic particles to behave that way, and given that Santa is made of molecules and atoms and hence subatomic particles, why can't he be in more than 2 places at one time? And it's not limited to just 2 or 3. Why can't he be in 1,000 places at the same time? Why can't he be in 1,000,000 places at the same time? So maybe he's figured out a way to do that, to use the subatomic properties, the properties that quantum theory tells us is how things behave on the small scale. Maybe he's figured out how to do it on a somewhat larger scale. And if, for some reason, Santa was not able to be in more places than one place at any given time, well, yes, he would then need an alternative way to make those deliveries. But again, there are alternatives available to him. Rather than him visiting all of these places, maybe Santa is able to manipulate and warp space and time. We know that matter does warp space, and we know that matter warps time. The most extreme example of that is a black hole. But in principle, any matter can warp space. And so instead of Santa having to visit all of these households, maybe Santa has figured out a way of warping space so that instead of Santa having to go to each of those households, he warps space and makes all the households come to him. No reason why not. Again, I'm not quite sure how he does that, but it's allowed by the laws of physics. So we've looked at children and visiting households, and we've looked at Christmas Eve. And the final thing we have to address is, how does he deliver all the presents when he does this? In other words, how big is Santa's sack? How could he carry all the presents? If it was one present for each of 1 billion children, how can the sleigh hold that many presents? Well, again, there's actually more than one way that he could do this. One is to warp space in such a way that the sleigh is bigger on the inside than it is on the outside. And if that sounds like science fiction, good old Doctor Who and the TARDIS, well, we know that is possible because, for instance, black holes are bigger on the inside than they are on the outside because of the way they warp space. So maybe Santa has figured out a way that the sleigh warps space in such a way that there's a bigger volume inside the sleigh than there is outside the sleigh. Alternatively, if you don't like that idea, there are other ways it could in principle be done. One option is to store the presents in a different dimension. All we can perceive are the 3 spatial dimensions: forward, backward, left, right, up, down. We are only aware of 3 dimensions of space. But many scientists believe that there are actually lots of dimensions, much more than 3. Maybe Santa has figured out a way of accessing one of these dimensions, in which case you take all of the presents in 3-dimensional space made by the elves, and then you push them into one of these other dimensions, and then you visit all of your households, and as you visit each household, you pull the presents back from the other dimension back into our 3 space dimensions, and then you place the presents under the tree. So again, we can't prove that's what he does, but if he did do that, it wouldn't break any laws as we understand them. But you might say to yourself, quite reasonably and skeptically, even if he was able to do all of these things, surely it would be impossible because it would all need a huge amount of energy if he actually wanted to achieve any of the things I've just been saying. If you want Santa and a sleigh and 1 billion presents to move at relativistic speeds in a 36-hour period, that would need an absolutely enormous amount of energy. True enough. But we know, for instance, that a black hole could power a starship, so why couldn't a black hole power a sleigh? In principle, a black hole could be used, the energy output of a black hole could be used to accelerate a starship up to close the speed of light and take us to the stars. We're not too sure how to build that technology, but we know the physics would allow it. And if we can power a very large starship, why can't we power a sleigh, even if it's a sleigh with 1 billion presents on board? Let's assume the presents aren't too big. Let's assume that each present to each child is a relatively small, compact present. So, powering a starship is possible. Powering a sleigh, why can't that be possible as well? But there is, again, an alternative if we don't like that idea. There's an energy source that I haven't even mentioned so far. It's the elephant in the room. What happens to all the mince pies? If people leave mince pies out for Santa, no one really believes he eats them all. How can one person possibly eat millions of mince pies over the course of a night? What if Santa could convert the mass of all the mince pies that he's left into energy? We know the conversion rate from mass into energy, E = mc². So if we work out how many mince pies he's left with, assuming he eats a couple but the rest are converted into energy, how much energy would he have at his disposal if he managed to do that? Well, we can do the calculation. For those that don't like maths, look away now, because we're going to calculate how much energy is available. One mince pie has a mass of about 50 grams. So mass times speed of light squared is 50 grams times c squared. That turns out in standard SI units to be 5 times 10 to the 15 joules. I'll come back to joules in just a minute. That's the unit of energy that physicists prefer. Rather than use an energy like calories, for instance, we prefer to use joules. If a few % of households leave a mince pie for Santa, let's choose a number that gives us a nice round number. Let's assume that 20 million households around the world leave mince pies for Santa. That means most of them don't. 20 million times the number we just calculated gives us a total of 10 to the power 23 joules at Santa's disposal, if he could convert the mass into energy. And I'm sure 10 to the 23 joules means absolutely nothing to you. So let me convert that into a number that you might be able to get your head around. That's the same amount of energy as the output of a nuclear power station running for 1 million years. Or if you prefer, over the course of a night, it's equivalent to Santa having the power output of a few billion nuclear reactors. Plenty of energy if he wants to get around really fast and deliver all of these presents. So a huge amount of energy if you can convert mass to energy of the mince pies. How might you do that? How do you extract E equals mc squared from a mince pie? Well, the most efficient way of doing that is to take your mince pie and collide it with an anti-mince pie. And you would do that in the Large Mince Pie Collider at CERN. But of course you then have the problem, but where do you get the anti-mince pies from? So there's a little bit of a catch doing it that way. So is there an alternative way of extracting energy from a mince pie that doesn't involve matter-antimatter colliders? Well, yes, there is a way of extracting not all, but perhaps most of the energy from a mince pie. There's a very efficient process of extracting a large fraction, large meaning 10%, 20%, 30% of the energy could be extracted from a mince pie if you dropped it into a black hole. Dropping matter into a black hole is an extremely efficient way of converting matter to energy. If you think about what our sun is doing, it's converting matter into energy by fusing hydrogen into helium. But that is a very inefficient process. The efficiency is less than 1%. In other words, after the sun has existed for perhaps 10 billion years, producing all the energy which is keeping us warm, its mass has only reduced by about 1%. In other words, 99% of the matter of the sun will still be there billions of years from now. Only a tiny fraction is converted to energy. However, dropping objects into a black hole could convert far more, 10%, 20%, 30% of the matter into energy. We know it's a very efficient process because we can see supermassive black holes into which matter is falling, producing what we call a quasar, a very active galactic nucleus. The most energetic of these are called quasars, supermassive black holes which are eating the matter around them. Dust and gas and stars, probably not mince pies, are falling into supermassive black holes, and a lot of the matter is being converted into radiation. These quasars can be so bright. During the COVID lockdowns back in 2020, I actually managed to image one of these quasars, even without a telescope. I obtained an image of a quasar on the other side of the observable universe, a quasar that's so distant from us, the expansion of the universe is actually taking it away from us at a recession velocity greater than the speed of light. This object that I imaged is moving away from us at twice the speed of light, but even at that incredible distance of 25 billion light years, it was still possible to produce an image of this object even without a telescope. That tells you just how much radiation was coming out of this quasar. And so, if quasars can produce enormous amounts of energy from matter falling into the black hole, then in principle, mince pies falling into a black hole could also produce a huge amount of energy. How much? Well, no matter how much I looked, I could not find any research papers on the topic of how much energy do you get out of dropping a mince pie into a black hole. So I don't know anybody that's doing this work, but I'm confident the answer is quite a lot. Okay, so these things are possible and there's plenty of energy available. But how could Santa actually do all that? Even if all of these things are possible and allowed by the laws of physics, how could it be, for instance, that Santa is able to manipulate space and time the way I've implied? Well, one thing to bear in mind is that, well, who says Santa has to be human? Nobody knows what Santa actually looks like because children are asleep when Santa visits. So, even though he has a penchant for wearing red suits, maybe he's actually got green skin. Who knows? So, is Santa compatible with the laws of physics? Or to go back to the original question, how many laws of physics does Santa actually break? I would argue that the answer is none. So feel free to draw your own conclusions about the existence, or otherwise, of the portly jolly fellow with the white beard and the penchant for wearing red suits. Regardless of the conclusion that you come to, may I wish you all in Anglesey a very Merry Christmas. Thank you very much for listening.